Hi, welcome to 5 Minute Math. This is Carrie Rhinehart. Today I'm going to be looking at factoring GCF. If you're following along in the book, this is Algebra 1, Unit 6, Lesson 1. So this unit is all about factoring. And when you're factoring, the very first thing you should always look for is a GCF. And if there is one, you should factor that out. There may not be one, but you should always look for one first when you're asked to factor. So factoring out a GCF is your first step in factoring. Remember, GCF stands for greatest common factor. So it's the largest value that you can take out of every term. So for example, let's do some constants or just numbers to start with. Let's say we want to find the GCF of 42 and 28. Okay. So we want to find the largest number that will divide into 42 and 28, and there's different ways of finding this. Okay, some students can look at it and just automatically say, oh, well, I see 14 will go into both of those numbers. Some students will say, well, I know for sure 7 goes into both of those. But it's really, it depends on how good you are with your multiplication tables and finding factors. If you can't just look at it, one way you can do this is to do a tree. So 42 I know is 7 times 6. 7 is prime, so I'm going to circle it. I can't take that any further. And 6 can factor into 2 times 3, and those are both prime. So the prime factorization of 42 is 7 times 2 times 3. For 28, I know that's 4 times 7. Well, 7 is prime, so I'm going to circle that, but 4 is 2 times 2. So the prime factorization for 28 is 2 times 2 times 7. And then to find the GCF, I circle anything they have in common. So they've got a 7 in common. So 7 is going to be part of my GCF. They also have a 2 in common. Okay. And that's all they have in common. So I multiply these two things, and I see that my GCF is 14. So again, you can either look at it, and some of you should be able to tell that it was 14. Others may need to do the tree. It just depends on how well you know your multiplication facts. But the first step is to find the GCF. You also need to be able to find a GCF if you're dealing with variables. Variables are a lot easier than numbers. So if I have x to the 10th and x cubed, and I want to find the GCF, it's always the variable with the lowest exponent because you need to be able to take it out of both of them. So x cubed would be my GCF here because I could take that out of x cubed, and I could also take it out of x to the 10th. But I couldn't take more than that. For instance, I couldn't take x to the 4th because there's not enough to come out of x cubed. So it's always the smallest of those variables, the smallest exponent. Another example is if I have, let's say, x squared y and x to the 5th y cubed. So I need to look at each of the variables separately. I've got x squared and x to the 5th. Well, the most I can take from both is x squared, if I'm going to take the same amount from both. And then between y and y cubed, the most I can take if I'm going to take the same amount would be y. So x squared y is your GCF here. And then sometimes you'll also have numbers and variables together. For instance, if I have 6x y squared and let's say 8x cubed. So first I'm going to look at 6 and 8. I know that the largest number that I can take from both 6 and 8 is 2. Then I'm going to look at my x's. I've got x to the first and x cubed, so the most I can take is just an x. And then I've got y squared, and I don't have any y's over here. So since I can't take a y from both of them, I can't take it at all. So 2x would be my GCF here. So that's the first step of factoring with GCFs, but then you actually have to factor it out. That means you divide everything, each term, by that GCF. So let's do an example. Let's say I have 2m squared n plus 6mn squared. My GCF here would be 2. I can take out a 2 from both 2 and 6. That's the largest number I can take out of both of them. I can take an m, and I can take an n. That is my GCF. So the first thing is you take out your GCF, and then you put a parenthesis here. We need to see what's left over after we factor that out. So you divide both of these terms by that 2mn. Okay, let me get a different color now. So the 2's here would cancel. M squared divided by m would just be m, and then the n's also cancel. Moving to the next one, so I've got plus. 6 divided by 2 is going to give me 3. Those m's would cancel. And then n squared divided by n is just n. So our final answer here, after we factor out a GCF, is 2mn, parentheses, m plus 3n. That's your final answer. All right, let me do one more. Let's say we have 4x cubed minus 12x squared plus 20x. My GCF for 4, 12, and 20 is 4. 4 is the most I can take out of all three of those numbers. For x cubed, x squared, and x, the most I can take is just x. So now I need to divide each of these terms by that 4x that I just took out. Okay. So the 4's cancel here. X cubed divided by x would be x squared. Remember, you subtract exponents when dividing. Minus 12 divided by 4 is 3. And then x squared divided by x is just x. Plus 20 divided by 4 is 5. And then those x's cancel out. So our final answer here is 4x times x squared minus 3x plus 5. And you could distribute that 4x back in to check your answer. Make sure that you end up with what you